Hi everyone, I'm Isiki from FKEE UTHM. Today we'll be looking at some exercise related to magnetostatic.
Alright, so now let's look at these questions. So you have to determine the magnetic field. Okay, wait. Magnetic field. Okay, at these positions. So these positions is your observation point, point P. So when there is 2 amperes of currents, 2 amperes of current, so this one is representing the I, okay, of current elements oriented from origin to this point. So what is origin? Origin is 0, 0, 0. Okay, so the first thing is we might want to have some drawing, okay, to illustrate our current elements. Okay, so if I draw in 3D, it will be something like this. So this is your current elements. Okay, so the current elements start from the origin and go to point 600. Okay, so this is point 6 of x-axis. Okay, so your observation point is this 301. So let's locate this point. 3 might be here at the middle. 301. Okay, 01. So it is the observation point, point P. Okay, so we have to find the magnetic field at these positions. So first of all, let's look at our current elements. Okay, there are so many equations for these to find this magnetic field. We have to identify whether it is an infinite or finite line. When we are looking at the dimensions of these current element, we found that we know what is the length. Okay, the length is 6 units, right? So if we know the length, this is a finite line. Okay, so for finite line, to calculate the magnetic field, we have to apply the equations from Biot-Savart's law. That is I over 4 pi r. Then we have cos alpha 2 minus cos alpha 1. Okay? Right. So this is the equations. Okay, so we know what is I, right? The I we know it is 2 ampere. So we have to figure out what is the R, what is the alpha 2, and what is the alpha 1. Okay, so and also this one, the phi components. So these 4 components we need to find out. So first of all, we find the R. So before we find the R, we need to identify what is the coordinate of point T. Okay, so point T will be again along the axis that has your current elements. Okay, so it will be along the axis here. Okay, so this one will be the positions of the point T, any position along this axis. Okay, so when the point is located at this axis, okay, the y value will be equals to 0 and the z value is also equals to 0. So for the x value, we can follow the x value of the observation point, okay, this point, which is equals to 3. Okay, so we will take the value 3 here. Okay, so we get the coordinate of our point T, which is here. Okay, this is our point T. Right, so let's find this as usual. So we have 3, 0, 1, minus 3, 0, 0. Okay, the answer is equals to 0, 0, 1. Right, so the distance between the point T and also the point P is equals to 1, and the unit vector R will be equals to z directions. Okay, so we get the value of our R. Okay, complete. Right, next we move on to finding the alpha 2 and alpha 1. So I will redraw again my current filaments. Wait. So my current filaments here. Okay, and then I will draw another axis. In this case, I will label these as X and I will label these as Z. Okay, so my current filament is from here, 0, 0, 0, extend those 6 unit, right, 6 unit. And my point T is here, right, this is coordinate 3. And my observation point is 3 and 1. Okay, so 3 and 1 is here. This is my point P. So you can join the point P with the end of your current filament, just joining them together. Okay, and for this one is representing your unit vector R just now. Okay, right. So let's identify where is alpha 1 and where is alpha 2. So for this point, I will label it as A because it has smaller value. And this point, I will label it as B because it has bigger values. So alpha 1 will stick with the point A. Okay, so this is alpha 1 and alpha 2 will be here. Okay, right. So let's calculate and the alpha 1. So maybe I will put some value here. This is 3 unit here and this is 3 unit here. Am I right? Okay, so for the tangent, 180 minus alpha 1, it is equals to opposite over adjacent. Okay, so this angle refer to the angle here, right? Okay. Alright, so using your calculator, I'm setting my mode in radians. So arctangent 1 over 3. So I get, if I'm using the radians, so this one should be pi. Okay, so pi minus alpha 1 is equals to 0.321. Okay, so my alpha 1 is equals to 2.82. Alright, okay, this is my alpha 1. So for my alpha 2, okay, I can use similar method, alpha 2. So opposite is 3 and adjacent is opposite is 1, adjacent is 3. So my alpha 2 is 0.321. Okay. Right, so we have got the value of our alpha 2 and alpha 1. They are here. Okay, alpha 2, alpha 1. Okay, and lastly, we will go to the phi. Right, finding the phi. Okay, so phi, wait. So phi is equals to dl cross with the r. Okay, so dl represent the direction of your current flow. So look at our diagram. Where our current is flowing in the x directions. So x directions. And our unit vector r is z. Okay, so x, z, we get negative y. Right, so we got everything now. Okay, this one also. Okay, negative y. So the last step is to just put them together. So the I is 2, 4 pi r, r is 1. Then you have cos alpha 2, 3, 2, 1 minus cos alpha 1, 2.82. And then the phi is equals to negative y directions. Right. Okay, so we can calculate this. Okay, so you will get your answer equals to negative 0.302 in the y directions, and the unit for the magnetic field is ampere per meter. Is it correct? Okay, so ampere per meter. This is the answer. This is our final answer. Okay, for our magnetic field. Right. All right, now let's look at these questions. So now we have a z and x axis. So we have two axes. Okay, the z and also the x axis. So both of them are carrying filamentary current of 20 amperes along positive z and 30 ampere along positive x. So calculate the h, okay, at this position. So this is our observation point, and we have two I, right? So this is I, okay, I1, I would say this is I number 2. Okay, so to find the total magnetic field at the observation point, okay, we have to find the magnetic field which is contributed by I1, okay, and find the magnetic field which is contributed by I2. Okay, so in this question, they didn't tell us what is the length, where is the starting point or an ending point. They didn't tell us. They just tell us the direction. Okay, so these two lines, okay, two current filaments, they are infinite current filament, infinite line, I would say, current filaments. Okay, so for infinite current filaments, the general equations to calculate the magnetic field is this: I over 2 pi r m phi. Okay, so the method to find the r and also to find the phi is the same like when we are doing for the finite line. Okay, finite current filaments. Okay, so the advantage of having infinite current filament is we don't need to find the alpha 2 and also the alpha 1. Okay, in this case. Right, so let's draw these current filaments in a diagram so you can imagine these current filaments. So one is the Z, then we have we have Y here, and we have the X here. Okay, so this is the Z axis, this is the Y axis, and this is the X axis. So our current filaments, okay, is in along the positive Z. So positive Z will be this one. Okay, positive Z. So the direction of the current flow, I1 is this. Okay, and for the I2 is 30 ampere in the X direction also. So we can draw it, okay, in the X directions. Alright, so this is our I2 and this is the I1. So where is our observation point? 6 at negative 6. So 6 at might be here. Negative 6, you have to go down. Okay, so this is just estimations. So it's somewhere around here. Our observation point. Okay, 6, 8, negative 6. Okay. So now let's find the H1. Okay, so H1 is the magnetic field due to the I1. So we have 2 pi r and phi. Okay, so the first step is always to find the point T. Okay, so point T refer to I1. Okay, look at I1. I1 is a current filament along the z-axis. So the x, the y, they are both 0. Okay, so for the z coordinate, we have to refer the z coordinate of our observation point, which is negative 6. Okay, now let's find the r. Okay, is 6, 8, negative 6 minus 0, 0. negative 6. Alright, so you have 6, 8, 0. And for the magnitude, for the distance, it is 36 plus 64 is equals to 100. When you square it, it will become 10. So the unit vector r is equals to 6, 8, 0 divide with 10. Okay, so as usual, we complete this part. Okay, so now next we need to find the unit vector phi. So unit vector phi is depend on the directions of the current flow and cross product with the unit vector r. So in this case, current flow in the z directions. Okay, our I1 flow in the z directions, and then we can cross product with this. Okay, this is x and plus at over 10 and y. Okay, so this is our unit vector r. So the number is just remain. So zx you get y. Okay, at over 10. So zy you get negative x. Right, so this is the value. So we just insert it into our equations. So the value of the I1 is 20 amperes, 20 over 2 pi. The R is 10 unit. And we have this 6 over 10 y plus, okay, we'll use minus at over 10 x. Okay, right, so try to simplify this and then you can calculate. Okay, so if we just put it like this, it is fine. Right, so the answer is this one. Alright, okay, so this is the magnetic field from the first current element, the H1. Alright, so now we'll proceed to the second one. The second one is the I2. So you can see from the figure, so the I2 is flowing in the positive x directions. Okay, so for the H2, our equations will be I2 because this is a magnetic field produced by I2. Okay, so using the same equations. Okay, again we need to figure out what is the R, but first of all, let's determine what is the T. Okay, so T will be a point that is along with the current filaments. So look at your I2, your current filament is located along Z-axis. So both the Z and also the Y, they are 0. So Y is 0, Z is also 0. So for the X coordinate, you have to refer to the observation point, which is 6, right? So the R will be equals to 6, 8, negative 6. Okay, so this is observation point. And then minus 6, 0, 0. Okay, so the answer would be 0, 8, negative 6. Okay, and then for the magnitude, okay, I think you know, okay, the magnitude is the same. Right, the magnitude is the same, is 10 unit. And the unit vector R is slightly different because of the polarity, the directions. So it is 8y over 10 minus 6z over 10. Okay, just divide it. Okay, right. Okay, so now we need to find the phi. So the current now flow in the x directions and it cross product with our unit vector R. So 6 over 10 z. Okay, so value remain. So x, y, you get z and minus x, z, you get negative y. Okay, so it will become positive y. Okay, it will become positive y here. Okay, positive y. Okay, so now we have everything. So we can put it in our H2 equations. Okay, so first of all, let's check what is our I2. According to question, I2 is 30. So we put 30 and then 2 pi, yeah, the distance is 10. And then we have this over 10 z. So this is our phi components over 10 y. Okay, right. Okay, so if we are doing this one, so this is 24 over 20 pi z plus 18 over 20 pi, okay, y. Of course, if you want to calculate the value, is also fine. So now we have this hash 1 and hash 2. So our final step is to add them together. So for the hash 1, let's see what is our hash 1. So our hash 1 is this, right? So I will take this. Okay, so this is our hash 1. And then add it together with our hash 2. 24. Okay, 24 over 20 pi. Z plus 18 over 20 pi y. Okay, so you can do the additions, x with x, y with y. So 8 over 10 pi x. So for the y we have 6 over. Okay, so the y has value is 0.477, and the z, okay, let's convert to numbers instead of fractions. So this is y, okay, and this is 0.382 z. So for the x, I also want to convert to number is 1/8 over 0.25. Okay, so ampere per meter. So this is our final answer. Okay, our final answer. Is it the same? Okay, all right, so it's the same. Okay, so the answer is correct.